Hello everyone, this is Vijay Jyoti. Well, welcome to Women Who Could Connect India 2020. We believe in Innovate Today for a Better Tomorrow. VMware is a proud sponsor of Women Who Code Connect India 2020, powered by VMware Nirman. Let me introduce our speaker Sridhar TR for the session Automation and Analytics in Cloud and 5G. Sridhar is currently working with VMware as a senior product line manager in the telco, edge, and cloud BU. He started his career as a developer at Siemens Information Systems. Later, he moved to Lucent and Dell EMC. He has extensive experience in cloud, operational support systems, IT, and optical systems for the telecom industry. He is actively involved in keeping abreast of cutting-edge deep learning research, evangelizing machine learning and deep learning in both industry and academic circles. In his spare time, he is also involved in many volunteering activities related to girl child education and nature conservation. Sridhar is a certified Google I Am Remarkable facilitator. He is also involved in mentoring activities for enabling women professionals to plan and pursue their career aspirations. Passing over to Sridhar. Please enjoy the session. Please use session chat window for question and answers. We will take that as time permits. Thank you. Welcome, Sridhar.
Hi Vijaya, thank you for the kind introduction. Good afternoon everybody. Welcome to this session on automation and analytics in the cloud and 5G world. So in today's agenda, we are going to see how the evolution of mobile networks has into the 5G world, where is the link between the 5G and the cloud, and how analytics and automation play a role for the 5G cloud. In the 2G and 3G world, what we see is the infrastructure of the cellular networks has three key parts: the air interface between the user's mobile device and the base station, the core network for the circuit switched voice network, and the core network for the packet switched data network. The reason why the two different core networks have stayed separate in the 2G and 3G world is because the technologies adopted were different. In the circuit switched voice world, it started off as TDM technologies, moved towards ATM, and then gradually moved towards IP and MPLS technologies. Whereas in the packet switched data, where we're talking about internet data, we are talking about IP and Ethernet, and hence initially the technologies were different. Let's see what the details are for the 2G and 3G architecture. We see that there is a mobile station, and then we also see that there is a base station subsystem. We see a network switching subsystem, and then overall there is an operation support subsystem framework as part of the 2G, 3G architecture. Going deeper, what we see as the subsystems of the network NSS layer, we see the HLR layer, the home location register, which is a database used for storage and management of subscriptions. We also have the MSC, the Mobile Services Switching Center, which is a central component of the network subsystem. It takes care of the call switching between the mobile and other fixed or mobile network users. We have a VLR, a Visitor Location Register, which is a database containing temporary information of subscribers who are roaming into neighboring networks. We also have the Authentication Center, which validates the SIM of the subscriber. And we have the EIR, or the Equipment Identity Register, as well. The idea of showing all these details is that each of these are separate applications by themselves, and all of these integrate to form the overall architecture. Now let us see what changed when we moved from the 2G and 3G world into the 4G world. What was earlier seen as a circuit switched core, or the voice network, separated out, and a packet switched core, which is the data network, has now become as part of 4G an evolved packet core, which is an all IP infrastructure. Now let us look at the network requirements of 4G. As we go there, we first need to understand the terminology data plane and control plane. The control plane is involved in setting up the call or the session, rerouting the session, and tearing down the session, of either voice or data. The data plane is actually involved in the transmission of the data, be it voice or internet. Coming to the requirements, we see that the data plane needs low latency, high bandwidth, high availability, and scalability. There is a need for aggregating the overall data reaching up to even 100 gigabits per second or even more. Data plane requires wire speed performance to be a key criteria, and there is a need for fine granular QoS because the data plane needs to segregate between critical applications or low latency applications or high priority applications compared to low priority applications like downloading of a large file. Coming to the control plane side, we see that the need is for high scalability and high availability and for network-wide policy and subscriber management. What we are seeing overall is that the requirements are completely different between what the data plane needs and the control plane needs from the network. Let us take an example of how Alcatel-Lucent, now Nokia, looks at the evolved packet core and how they distinguish between what the data plane requirements are and control plane requirements are. The control plane subsystems have now evolved to such a stage that they can be housed on ADCA platforms, essentially off-the-shelf platforms. And key examples like MME and PCRF functions we can see have requirements which are served by standard off-the-shelf processors. Coming to the data plane, we see that predominantly the NEPS providers deliver it over proprietary routers. So for example, the serving gateway or the PDN gateway, we see serves large number of eNode Bs and focus on highly scalable and secure data connectivity. These are achieved only through proprietary routers as of today. The idea of segregating between the data plane and control plane requirements is to say that the evolution of control plane towards the cloud is on an accelerated path, and the data plane is going to take some more time to move towards the cloud. Let us take an example of IP multimedia subsystem, which is an application in the 4G and the 5G world. On the left, we see an IMS architecture where we see the different components or the subsystems. The EPC has got HSS, AAA, MME, serving gateway, and packet gateway components. And these are realized over multiple virtual subsystems as we see on the right. Now we move to the 5G world and see where the link to the cloud comes. The technology drivers for moving to the 5G world, the obvious one is obviously the high speed, resulting as an effect of the technology advances made in the massive MIMO. But there are additional technology drivers which are coming through the effect of Cloud RAN, edge computing, and network slicing. Looking on the business and the market drivers, we see that the timing that the network functions are getting virtualized is a critical aspect of that. The scale of the end devices as well as the services results in a critical need for scaling out or scaling in, and this is served predominantly by the cloud use cases. There is a huge flexibility requirement, which results in significant cost savings for the CSPs. And there's also a critical need for optimal positioning of network functions. Each of these drivers are facilitated by moving to the cloud. Let us look at one of the technological advances, namely the virtualized RAN. A traditional RAN architecture had the remote radio unit as well as the BBU located close to the cell site at the tower location, and this was resulting in significant non-optimal utilization of the RRU and BBU. Now, by moving the BBU functionality and certain aspects of the RRU functionality more towards the core, we are able to optimize and statistically multiplex the utilization of these core functions and hence help in reducing the OpEx for the operators. What is also implied in the slide is by moving these functions to the core, there is a need for them to become virtualized and go on to the cloud, resulting in the cloud link in the 4G and the 5G world. Let us look at cloud evolution, which is aiding the rollout of 5G. There is a significant movement from the centralized cloud to the distributed cloud. Traditionally, when any CSP were to deploy functions on the cloud, they used to get locked into a particular centralized cloud. But now, with the evolution of hybrid cloud, we see that the enterprises have options to move the functions across the centralized clouds, as well as to utilize on-prem infrastructure which has already been invested by the enterprises. Similarly, there is also technological evolution for seamless expansion to hybrid cloud. Essentially, moving our functions across the clouds is like achievable over a click of a button. The requirements on the latency and the regulation are also driving the cloud adoption. GDPR, which requires the ability for the data to be housed within a particular country or a continent, drives that the certain cloud functions need to be deployed within the respective continent itself. What is also driving cloud evolution is that VNFs are becoming common and getting to become a commodity. One other aspect which is significantly driving cloud evolution is the availability of services, the VNFs, as a subscription model and not as a licensing model. With all these drivers coming in towards the cloud adoption, there are significantly varied estimates, however, indicating that up to 80% of the enterprises will be adopting cloud even by 2025. Let us now see how analytics and automation play a role for the 5G cloud. Gartner has indicated that by 2022, 50% of the value generated by advanced analytics, artificial intelligence, and machine learning across a communication service provider's operations will come from better network management by using technologies such as self-optimized networks, up from the 20% today. What we see on the right is the different applications and how they will contribute to the overall use of analytics and automation. One of the key factors or the key players in this space is the network IT operations monitoring and management. But we also see the gradual adoption of customer service and marketing VDAs, intelligent CRM systems, improved customer experience management, and other applications including predictive maintenance and fraud mitigation. Let us now see some of the details on how network can be facilitated by AI and ML. Anomaly detection for operations, administration, maintenance, and provisioning, OAM and P, is going to be a significant use case in the network operation monitoring and management space. Performance monitoring and optimization, again, is a critical aspect for the CSPs to deliver on the SLAs for their customers. Alert and alarm suppression is a big focus area for the CSPs. Typical 4G and 5G networks are going to result in tens of thousands of alarms per day. And there is no way that a human operational force is going to help to resolve all these alerts and alarms. Recommendations on trouble ticket actions are going to become a key part again in optimizing the operations of network management. Automated resolution of trouble tickets, essentially self-healing, is going to be a critical part during the adoption of 5G. From the aspect of how we go about resolving an issue, AI and ML are going to play a key part in the prediction of network faults, and hence result in not landing into scenarios which is going to degrade the services delivered by the CSPs. Network capacity planning and essentially congestion prediction is again going to be a key part of how AI and ML are going to be utilized by the CSPs. Let us go to the applications of AI and ML. Detecting and predicting issues for network operations, faults, service level agreement breaches in real time is going to be a key use case. Finding correlations between alarms is also going to be a key aspect. Diagnosing root causes, correlating across multiple event sources, filtering out false alarms is also going to be a focus area for the CSPs. Prioritizing the alarms based on the topology and network telemetry is going to result in lower number of alarms, and lower number of activities for the human personnel involved in monitoring the network. Automating the service assurance for resolving the common incidents, essentially either through supervised mode or through open loop operation mode, is also going to be critical for the CSPs to achieve benefits of scale of 5G world. What is also need to be called out is that the existing service assurance solutions having AI and ML capabilities need to go through an adaptation phase to the 5G and NFV world. And this provides a critical opportunity for people who want to get into this space and disrupt this entire ecosystem. I thank the Women Who Code event organizers for giving me this opportunity to speak in this forum. Thank you, and back to you, Vijay.
Thank you, Sridhar, for the deep tech drive. We have a couple of questions from audience. Like, will fiber deployment patterns change when 5G is deployed?
Sorry, can you tell that again, Vijay?
So, will the fiber deployment patterns change when 5G is deployed?
Exactly, yes. So there's going to be a significant change in how the deployment is going to take place because the cell site radius in the 5G radio is going to be different. 5G radio has evolved to a stage that it can have coverages of fewer radius compared to the 4G world. And we do not foresee a scenario where 5G is going to be deployed in a large scale. Initial rollouts of 5G are going to happen in point-based scenarios, and hence there's going to be complete need for rethinking the fiber deployment.
Okay. And we have one more question. Like, can 5G and 4G exist in the same spectrum? So I think it is all.
Yes. Yes, I think that is going to be a key factor driving 5G. What 5G does is to aggregate spectrum from various bands available in the different countries and also to stitch them together to give a higher bandwidth. So any sector where 4G is deployed can plan their 5G deployment in the spectrums not used and gradually move their 4G rollout into 5G spectrum as well. So this aspect has been factored in while 5G standardization has been evolved.
We have one more question. Like, when 5G is deployed, do we have the backward compatibility with 2G and 3G?
Yes, that is going to be a critical factor, and this has already been factored as part of the standardization process. So there are going to be gateway functions when 5G needs to talk either to a 4G network or even to a 2G and 3G network. What is also going to be factored in is while 5G is being deployed, many of the countries are going to redeploy their 2G, 3G spectrums to 5G. So the need for interop is going to decrease over time. And we see that over a period of time, there will only be a superimposition of 5G and 4G networks to optimally utilize the 3G, 2G bandwidth into 5G.
Okay. Thanks everyone for attending the session, and thank you, Sridhar, for explaining the answer in detail. So I just wanted to wrap it around, like in this session, we learned about like 5G and cloud evolution from movement from centralized cloud to distributed cloud, and analytics and automation challenges for the 5G cloud. Thank you, Sridhar, once again. Before we wrap up the current session, let me remind you all about other sessions which are lined up. Connect with communities, VMware, Inclusion Tara, all you need about DevOps. Also, don't miss the closing note where we will be announcing the winners for quiz. Thank you all.
Thank you.